Hi everyone, welcome to Black Hat Briefings. This is the Turbo Talks 20-minute sessions. This is Mike Pomraning. He's going to be talking about injection flaws. Please turn off your cell phones.
Hi everyone, thanks for coming. I'm Mike Pomraning and this talk is Injection Flaws. Stop validating your input. How many of you in the audience are familiar with SQL injection or cross-site scripting flaws? How many of you have authored code introducing one or both of those flaws into an application? That's very bold of you. How many of you have come across such code in a review or fixed such code or have just been disgusted by the appearance of such code in the daily vulnerability feeds? Okay. This presentation was originally about 50 minutes, so we're going to start on slide 6. We're going to skip the background. Which pretty much establishes that we will only be focusing on SQL injection and cross-site scripting, the two most common kinds of injection flaws we see exploited, and whether or not we can do anything a little bit differently about them. The conventional wisdom regarding these two flaws is that they are input validation errors. Now, this is a very common sense and pervasive taxonomy, and it makes sense. You know, I intuitively want to regard these as input validation errors. It's kind of enshrined, for me at least, in the security-focused bug track ID classification system. If you chase down your favorite SQL injection or cross-site scripting vulnerability and go to the security-focused, pull up its BID, they'll have it classified as an input validation error. It's in the language that we use to talk about these things. The two CVE IDs up there, I think 0040 regards an open source PHP application called Cacti, which is a front end to the RRD tool, if any of you are familiar with that. And the latter is project, I'm sorry, that was a SQL injection flaw in Cacti. And the latter is a cross-site scripting vulnerability in .NET Nuke. And I don't mean the CVE entries themselves perpetuate this language, they do not, but the original advisories, one from iDefense and one from an unaffiliated security researcher, say quite plainly, due to a lack of input validation, this application is vulnerable. In the case of Cacti, there are at least two OS vendor follow-up advisories from Debian and Gentoo, I think, that mirror the same wording. You know, if only the input validation had been better, this wouldn't have happened. There was an error in input validation. Poor Cacti had a counter advisory to these advisories from Stefan Esser of the Hardened PHP project. This was all, check out Esser's work in this month, I think. He's got a lot of advisories that have come out. Bug track and full disclosure, they really get at some of the subtle attacks you can do with SQL injection and cross-site scripting. But again, he says, you know, the input validation routines put forth to fix the first problem were not good enough. And so as programmers, we're hearing something we've been hearing for a long, long time. Validate your input. Validate your input. Oh, you were bitten by that bug? Oh, if only you'd validated your input just a little bit better, that wouldn't have happened. You know, arguably, we've been hearing this since at least the GNU fuzz tests at the start of the last decade. It's the same kind of principle, right? We all agree validating your input is good. Input can pervert the program if it's not as you expect. But boy, it just doesn't seem to be helping the situation. I kind of think of it as running up to the scene of a recent car accident, throwing open the door and seeing the driver, and they're kind of groggy and injured, seeing that the driver's not wearing a seatbelt, the driver has no airbags, and saying, wow, if only you'd driven a little better, this wouldn't have happened. Maybe there's something else we can do to mitigate these attacks. If we regard this as input validation errors, what kind of mental model does the coder have when he says input validation error? Because when you say something is an input validation error, you're classifying it on the basis of a defense. You know, if we say it's an injection flaw, we're classifying on the basis of the mechanism of exploit. But when we say it's input validation, we're saying, oh no, this classification is one of defense. The technique is to validate your input a little better. And I think what it really does is keep our eye on the attacker out there, you know, kind of adopt a perimeter model where we are baggage screeners or front desk security guards saying, I'm going to stop the bad stuff from getting in and let just the good stuff go behind me. And so I'm not sure that that's terribly effective, and certainly it fails. Let's take a look at validation and see if it's not everything we think it's cracked up to be. Rethinking input validation. The first thing you always hear in the validation debate is the complaints about undesirable data set restrictions, particularly when people can't make a distinction between encoding data for representation in a particular subsystem and getting rid of characters that might pervert it on its way to that subsystem. So we don't want that tricky backslash to get into our application, because we know that can be used for SQL injection. But we need the backslash if we're representing Windows path names or Windows fully qualified usernames. If we're writing a bulletin board application for algebraists or something, we're going to need a lot of punctuation characters. We're going to need to let greater than and less than appear so they can have the kinds of discussions they want. We can't just unilaterally exclude these. And there's a very predictable debate that I'm sure many of you agree with me has been done to death. Do we whitelist the characters? Do we blacklist the characters? Have we exhaustively and correctly enumerated the set of characters that we want to allow or disallow? What if we're wrong? It just goes on and on. The second thing I don't really like about validation is the primacy of regular expressions. Regular expressions are king. Now, I love regular expressions, but I think they're kind of a complicated mini programming language. And many of you, I'm sure, have seen regular expressions authored by others, perhaps authored by yourself, that you look at them and they're just obviously not right. How many times have you observed this kind of back and forth? You know, we need something that'll validate a simple token. Coder says, okay, A through Z, big A through big Z, 0 through 9. Well, hang on there, rookie, you forgot to anchor that. Oh, okay, there you go. Oh, wait a minute, I'm sorry, we can't have A through Z, 0 through 9. We must restrict it so that the first character is not a number. You know, let's say it's a C-style token. Okay, so we'll put 2 atoms in our regular expression, and it gets a little more complicated, and someone steps in and says, okay, accept that, and also accept a dotted quad address, which is one of the notoriously difficult things to do. People have, you know, masculinity contests for how cool their regular expression for validating dotted quad IP addresses are. And programmers don't have sufficient training, I don't think, in regular expressions, and many of them don't want it, and so we see a lot of cargo cult application of regular expressions. You know, this regex appears to safely validate input in this application. My data types are kind of similar. I'll lift it, maybe translate it from Perl into whatever I'm using, Java regular expressions, and I'll go from there. And it's not being done quite correctly. A validation problem that's shocking, but quite prevalent, I think, is validating the wrong thing at the wrong time. People are probably not mentally diagramming the flow of data through their application. You know, data comes in off an input channel. You have layer 6 concerns about the presentation. You need to get it into some kind of normalized state and denude it of any kind of encoding transport that it's had. Then you can apply your validation routines. Then you can inspect it to see that it's what you want. Then you get ready to pass that data to the output subsystem. It's a SQL database. It's an end user browser. You again have a layer 6 concern again. You have to encode it properly for that output mechanism. We've all seen the vulnerability announcement on Bug Tracker, full disclosure, say, where a CGI script is vulnerable to, you know, script alert, I've got your cookies, end script. I don't mean to trivialize that. Those of you who saw Jeremiah Grossman's Phishing with Superbait presentation know that cross-site scripting is no laughing matter. And the attack is ineffective when we simply type less than, script, greater than, and go on. But it is effective when we encode those same characters for HTTP. And that's just ridiculous. Those of you who have done CGI programming know that what must be going on is the application coder is reaching behind his CGI abstraction to get to the raw text submitted by the web server, still encoded in HTTP, still with all of its transport garb, and applying the validation there. And then later, we'll probably be using the CGI API to pluck individual tokens. You know, what was the value of that input variable, where other transformations are occurring. And that's just ridiculous. You know, we have two passes that we really care about in the common application where the data comes in, data goes out. We have the first pass of validation where we want to make sure that the data is the correct data type. You know, do your monetary fields look like currency representations? Do your strings look like strings? And then we have the second concern of validation, which is to see that the data doesn't have syntactical meta characters that are going to confound the output device, that are going to screw up what we intend to do on the SQL server or in the browser. My favorite validation misstep, you see this every once in a while on the vulnerability news feeds, is the pre-encoded attack. You know, we're trying to attack a web application. We want to get a JavaScript protocol handler in. We know the web application is dynamically generating an A tag, and we can control the value of the href attribute. So we try JavaScript. Doesn't work. Maybe we're kicked out of the web application. We try JavaScript in uppercase. Doesn't work. Oh, this is a clever programmer. He's case insensitively looking for JavaScript. And we think, well, he's probably not encoding the output just prior to echoing it to the browser. What if we do it for him? What if we turn the C and the colon into their HTML escapes? Now, you know, the coder's filter sees the literal string of bytes, JAVAS, ampersand, hash, 99, and so forth. It does not see the token JavaScript, lets it write on through, and this renders just fine in the browser. The alert pops up, the cookies are stolen, it's calamity. Similarly, with relational database systems, if you are a beginner to perhaps an intermediate SQL programmer, I suggest you take a look at the full grammar supported by your SQL server. And I expect you will find it to be kind of an exotic superset of what, you know, sterile ANSI SQL is. What are the quoting and escaping conventions? How do you escape a quote within a quoted string? Do you backslash it? Do you double quote it? What does it do with hex literals? That's an interesting one to see. Does it support interpolated variables, kind of like the shell? If there's any wiggle room between the data that you're going to pass to between the data that you're going to pass to your subsystem, SQL Server or the output browser, and that subsystem's understanding of meta characters, the attackers are going to find out. They're going to try automated methods to discover this. The attackers, at the end of the day, fundamentally know the inner workings of these things a lot better than we do, most coders. The final thing that's tough about validation, and raise your hand if this has affected you, it lacks precognition. It certainly affected me. It can't see the future. Many of the deferred or second-order attacks that we see with these injection flaws, I think are attributable to coders just focusing on what they're doing with the data right then and there. You know, they're not thinking about what's going to happen. Once they get rid of it, they're throwing it out to another subsystem, and that'll be somebody else's problem later. Of course, you could argue that, you know, the problem is actually later when they read it back in. We'll get to that. Even where the output subsystem is known and fixed, the output subsystem is not really fixed. End-user browsers are a great example. Those of you who remember Gobble's security advisory number 33. Gobble's details a kind of JavaScript entity encoding that's only, as far as I know, supported by Netscape 4, I think it is. It's a pretzel curly brace. Alert, I've got your cookies. You know, if your validation routines are just looking for kind of classical HTML ordinary ECMA script attributes, it won't see that. Similarly, your IT department might suddenly decide to bring you into 2003 by upgrading that MySQL server that they've had running since 2000. You know, we do things slowly. The quoting and escaping conventions are suddenly a little bit different, a little bit improved. Variables, interpolated variables have been introduced in the SQL server. Input sources can also change, which is a very interesting riff on this, particularly as complicated projects are maintained and extended. Cacti, actually, the Stefan Esser counter advisory noted that the input validation routine that was developed for Cacti was applied to the underscore request variable, whereas the actual application was using the value of user-supplied input from the underscore get variable. Those of you who are not familiar with PHP, there are many different ways to pass input into the PHP application, and request and get are kind of magic variables that represent different views of the HTTP request. And simply put, they were validating the wrong input stream. They did their validation check over here, their use over here, and they pulled the input from different sources. The worst thing about validation is that no one actually does it. Validation is inspectional, right? In almost any, outside of web application security, when we're talking about validating something, we don't mean we're transforming it. We mean that we are establishing its correctness or soundness, right? We are not making a material change to it. But you know, that's not what we mean when we talk about this in a web application security context. And part of it is perhaps because nobody has the patience for it. I certainly don't. I don't want to have to develop a system whereby if I see a bad character in a username, I have to report back to the user that the username was rejected for this reason. Please try again without that character. I don't want to have to develop the logging and auditing subsystem for this, introduce a lot of complexity to support this. I'd rather just have kind of a straight through flow. When the data comes in, I do something to make it safe, and then I just keep going on and on. So what do? We mogrify the data. We transform it, and we read things like, the best practice is to strip special characters. That's a best practice from a document written this year. Just look for anything that might be kind of a syntactic meta and take it right out. There are 3 models for data validation. Now with OWASP Guide version 4, there are 4 models of data validation. Accept the data. Okay, we've identified it as good. We'll go on. Reject the data. We've identified it as bad. We will invoke our error handling routine and communicate that back to the caller. Or sanitize the data. Do something to the data to make it different. And you see regular expressions come back here with a vengeance. The sed style S / notation is used pretty extensively in Perl CGIs to get rid of those terrible characters. I think in general we've seen that the client-side approach to input validation has left, we've brought it indoors. We've taken our regular expressions and our length checks and whatnot, and we put them on the server, and that's good. But we're still kind of looking outside. We're still focusing on the attacker. We're not paying attention to the subsystems that are actually going to be perverted by the input. And I think in the discourse there is a real conflation of terms. When people say stripping or sanitizing or scrubbing or filtering or validating or encoding, I do not believe that it is clear to a collection of 5 people what exactly is meant. After the phishing speech, a number of us descended on Jeremiah and tried to talk about defense strategies. And there was substantive confusion. It took a long time to figure out where we were talking about a hypothetical ad. Were we in the input routine itself? Were we in the canonicalization routine? Were we actually doing validation? Because some people were talking about sanitizing. Some people were talking about filtering. Some people, it's not quite clear to people what's going on here. And that's not a good thing. So let's turn it around. Let's not try to fix that problem. Let's not try to disambiguate. Let's just forget about it and do something else. Let's not focus on input. Let's focus on output. This is our last chance to defend, right? Your web application firewall failed. Your server hardening module was misconfigured or shut off, or it was tricked. Your input validation routines are totally broken. They were written by that noob in the other cubicle. He doesn't know what he's doing. And you're in this one segment of code where you're about to hand the data off to the subsystem. What are you going to do? We're looking for something that is a discrete and tactical coding practice. We want something very specific. We don't just want to tell people, validate your input better. We want to say, do this exactly. We want something that doesn't care about what the data looks like, right? We've given up on it. Maybe the data has tainted characters, maybe it doesn't. It's too late. That's not where we are in the code. We want an API abstraction that totally conceals the mechanics of how this functions. We don't want programmers to have to reinvent things. We don't want them to go down that regular expressions path again and everybody come up with a very complicated Rube Goldberg type machine that doesn't necessarily work. Do you remember what we did when format string vulnerabilities were a big problem? Where there was a discrete tactical change that we could all make to our code that would more or less fix it. It was not a 100% solution. There was that locale trickery that one could pull. But we stopped letting users supply the format string to printf and SN printf and that sort of thing, and that largely took care of the problem. Is there anything similar we can do for SQL injection and cross-site scripting? There is. Defense techniques, lessons learned from layer 6. SQL injection is largely solved by bind variables. This is your 95% solution right here. According to one of the sources at the end of the presentation, this is the internal coding standard at Oracle. One of the conventioneers here told me he believes it's the internal development standard at Microsoft. You'll see different names for this. Placeholders, prepared statements, precompiled query plans, parameterized queries. Parameterized queries is arguably a better known term than bind variables. I've come to this from kind of the Perl perspective, so that's why I chose bind variables. And what it does is provide proper syntactical interpolation of anything you throw at your templatized query. We've got select secret from table where user equals question mark or hook. We take our user supplied data and we cram it into that question mark. And the driver magically encodes it and escapes it and quotes it for us. And suddenly there's no problem. The syntactical structure of the query we intend to execute is preserved. They're not sticking a union in there. They're not sticking comments in there and an end of statement and then a drop all tables. Now, the query may fail. There are semantic problems here, of course. They're going to feed us garbage. We're going to be looking for something. But we're not injuring anything. We are not allowing the attacker to execute arbitrary queries on the server. Most bind variable implementations support that hook style notation. The principal limitation, I think, of bind variables is that you can only do this on like dead SQL scalar data. So for example, in the query there, the tokens secret, table, and user cannot be dynamically generated in a safe fashion. Only the value of constraints in your where clause can be amenable to bind variables. But in practice, that's what we need. And in practice, that's what people are doing when they're pasting together these insecure SQL statements with user-supplied data. The question mark there represents the thing that they want to interpolate. Database-independent APIs are preferred, at least by me. So let's take a look at some of those right now. JDBC, anybody use this particular feature of JDBC, the prepared statement? You can get your SQL statement together, and let's say username and hash pass are what we want to supply. We identify the hooks by their position. Hook number 1, hook number 2. There's a sophistication with callable statement, which I think is for stored procedures, where you can name the parameters. That's a little bit easier. ODBC is very difficult for me to look at, but it can accomplish much the same thing. There are higher level interfaces to this that are a lot more tolerable. I'm sure this one is well known here. Perl DBI, of course, supports it. The execute method is what takes your bind variables. If you're familiar with the way that the Perl does the DBI and DBD, you know that it's it allows you to talk directly to the driver too. So if your driver supports something better than Perl, you can use it. PHP, you got to go to the pair, or you got to go with ADODB to get something that supports this, but it is there. And I would argue that with its presence in pair, there's really no excuse for anybody to be kind of manually generating these dynamic SQL queries anymore. Python is one of my favorites simply because it natively supports this named substitution syntax, much like it does for format strings in general. And their API allows a very flexible specification of what those bind variables look like. Cross-site scripting, very simple. Output encoding. This problem here with double chocolate bid 12894, very indicative of the kind of solution you see to cross-site scripting vulnerabilities. Well, all we're doing is identifying the part where a variable is being spat back out to the end user, and we're calling HTML special characters. If you're doing this in Perl, you have the HTML : entities module, I think it is. If you're doing it in Python, you have a CGI package. If you're doing it in other languages, I'm sure you've got something. Output encoding has been mentioned at least as far back as the CERT 2002 advisory on cross-site scripting, but it's kind of always getting the second chair. It's not talked up a lot. The CERT advisory says something quite odd, like output encoding may be resource intensive. Which is kind of shocking. The right thing to do is to encode everything just prior to output everywhere. If you are echoing anything that is raw to the end user, you're doing it incorrectly. You're setting yourself up for a cross-site scripting hole, if not in the current release of your package, in the subsequent release. Anybody remember Diabolic Crab from BugTrack? Guy was getting SQL injection cross-site scripting advisories out like once every other day. He says at the very bottom, use HTML special characters. And that's really all that's necessary for most of these PHP cross-site scripting attacks. You'll want to set your content type to match the expectations of your encoding routine, and you'll want to use double quotes on dynamically generated attributes, because I don't think special characters encodes double quotes. But other than that, that takes care of it. A templating system is something that you can use. Make a picture of what you want the output to look like, and then trust that the templating system, say HTML Mason will do this, takes any data you plug into that picture and encodes it properly. There's no problem. I don't have time to get into remarks on HTML permissive content management systems. That's the path to madness, I'll say. All right, concluding remarks. You got to use bind variables. You got to encode your output. This is the very first thing you need to do. When you get in your car, you put on your seatbelt, you turn on the airbag. Then you worry about what the actual road conditions are going to be like. The first thing you need to be doing when you're coding these things is using bind variables and encoding your output. Get it into your coding guidelines, your review, and your documentation. If you write modules and libraries, make sure that you lead with these secure examples. The third thing you need to do is use bind variables and encode your output. It's really quite important. The fourth thing is to identify trust boundaries. I think there is a real confusion. People don't sit down and think about their software as interrelated components and trust boundaries. The incoming trust boundaries are more or less easy to identify, but the outgoing trust boundaries, we don't turn around often enough and say, oh, I'm passing to a different subsystem. There are concerns about the representation of this data. Fifth, bind variables, output encoding. Really, honestly, that's what you need to be doing. And finally, do validate your input. But be precise in your terminology. What are you validating? Why? What is the purpose of your validation? Are you doing it to see that the currency field looks like a monetary value? Or are you doing it to see that the currency field doesn't have SQL meta characters in it? It's going to have a bearing on how the application looks. And finally, let me just skip ahead a little bit here. Be very careful when you read the references at the end of this presentation. Not all of them are correct. Some of them I have selected because they are indicative of the wrong way of approaching this, I think. So, tread lightly. If that's not legible, my email address is mjp-bho5. That's Mike Juliet Papa / Bravo Hotel 05 at securepipe.com. And I'm happy to take any questions. Oh, it is the OWASP Guide version 2, which is a fabulous document, despite my objection to the placement of sanitization as a species of validation. If you've not looked at the OWASP Guide since version 1, and if you didn't go to Andrew's presentation, go to the website and get it.
We also recommend strongly output validation if you don't trust what's currently inside the database.
Marvelous. The OWASP Guide has lots of good recommendations. Yes, sir.
So the primary reason why developers actually do SQL annotations, they're actually looking at doing queries that are hitting many different tables potentially based on many different possible inputs. Instead of them developing a matrix of 7 by 7 or 7 inputs, 49 different sort of procedure things, they actually chase and they do this get past query like user interface. So what do you do to make it easier for developers to stop them? They're lazy. They're always lazy. Right? Stop them from, because they're going to look at it and say, I don't want to make 49 different separate SQL statements that are recognize queries. That's the driving force for that kind of behavior. I mean, it's simple. Just like taking something from the first table to the first table.
Are you suggesting that the programmers are dynamically generating queries based on things that bind variables can't handle, like table names, or dynamically generating like where constraints and things like that? That is just a simple matter of programming, I find. Now, it's... Indeed, and that's why I think this needs to be built into coding recommendations. You can do it, certainly. As you're piecing together the field and the value, you can keep track of how many hooks you're inserting. Mm-hmm. I agree. In my experience with code snippets posted on the vulnerability news feeds, however, it is nothing that exotic. The programmer is literally interpolating a string, select blah from table where user equals $foo. And it's not a complex building up of a query. Sure, and this doesn't need to be preloaded as a statically generated matrix. You can dynamically generate it from a couple of known arrays and kind of lazily evaluate this. But the point is, when you call execute, you'd better be using bind variables. And I don't think it's actually that difficult to follow it. If you can go through the trouble of initializing that big matrix or of lazily generating it, you can certainly go through the trouble of keeping track. Oh, I've got another bind variable here. Oh, I've got another bind variable here. I should think. Other questions?
We have toolkits that allow us to do input validation fairly easily, but the output validation techniques we've seen here have been scattered among different parts of programming languages. Is there any one toolkit that incorporates a lot of these output validation techniques as kind of a one-stop shop?
As a small point, I wouldn't call it output validation. I would call it output presentation or output encoding, because again, we're not actually inspecting the character of the data at all. So I really think we're doing a disservice to call that validation. No, the generic APIs for database queries all generally support bind variables, and in language-specific CGI development, you need to find your language-specific HTML encoding function.
One more question? All right. Thank you, Mike. That was a very